Now we'll take a look at how we can use the completing the square method in an application problem. So if we look at sample problem number 4, what I'm going to ask you to do is to do your best to go ahead and work this first, see how far you can get through it, and then come back and see the problem worked out. And so I'm going to go ahead and work this now. If we notice, this toy company has a function that models the sales, and so the dollar depends on the price of the toys. So part A wants us to complete the square and write the function in vertex form so that we can graph it a little bit easier. So we're going to start off with this S of p equals negative 50 p squared plus 3,000 and p. Now the first thing we want to do is, in order to complete the square, our leading coefficient has to be equal to 1, which means we really need to factor out the negative 50. Now we have a value here that we can complete the square with. Now this is going to be a little different than what we've seen before. If we complete the square here, I'm just going to take the c value as negative 60 over 2 squared, which gives us negative 30 squared, which is a positive 900. Now we showed you in an earlier example that if we add a 900 without adding it to both sides, we technically also need to subtract that at the same time. Now this is going to leave us a little bit of a different problem here, because really what I want to do is I want to be able to just have this 900 so that I can complete the square. But everything inside this parentheses is technically a multiple of the negative 50. So in order for me to get the negative 900 out of here, I need to multiply it times the negative 50. And so that will end up giving me something like this. Negative 900 times negative 50 is a positive 45,000. So I'm going to multiply that, kind of like distributing, but I'm only distributing one singular part of it. And so now I can actually write this in vertex form. And then we have the equation that we need. And so if we look at this very carefully, we have a vertex that is 30 and then 45,000. And it says to graph this. It says to draw your own scale for graphing. Complete the graph, draw your own scale. So what I'm going to do here is I'm going to use my understanding of what this graph should look like. Now if we look at this, I can see that I have a negative there, and so my graph probably looks something a little bit like that, with the vertex being up here at the top. Now keep in mind here, this is representing dollar values, so really there's no need to come down into the negative numbers for the dollar values. We only need the quadrant 1 graph. Now it says to create your own scale. Notice that the 30 is representing dollars and the 45,000 is representing dollars, and so we need to create some sort of scale on each part as best we can. And the same thing on this axis. And so for the bottom axis, we've got maybe 10, 20, 30, 40, 50, and 60. On the top axis, however, I want to get to 45,000, so maybe I need to do this in 10,000 increments. And so we know that 30 and roughly 45,000 is going to give us 1 point, which is our vertex. The other thing that we really know is that if we have $0 in sales, and for our price, it's going to give us $0 in sales. And of course, we can use our understanding of symmetry here. So if our axis of symmetry runs through 30, then $60 price is also going to give us 0 in sales. And so our graph would look something like that if I could get it right on the 60. Now, part B of this problem basically asks us what is the vertex of the function, and we already kind of defined that as 30 and 45,000. It says, what does the vertex represent? Well, the first part represents the price of the toy, and then the second part represents the sales that we would obtain with that given price. So at $30, I can expect $45,000 in sales. Now, the second part, or this last part, the third part, says the model predicts that the total sales will be $40,000 when the toy price is $20. At what other price will it also be $40,000? And so if we look here, if we look at $40,000 price level is roughly there, and we can see that, roundabout in my scale, that gives me a $20 price tag. Well, if we know symmetry is working here, we should know that this other place that hits $40,000 in sales would be a $40 price tag. And so we can use our graph to do that, or if we wanted to, so we basically could see that $40 in sales, a $40 price model will give us $40,000 in sales. Now we can verify that by evaluating at $40. And so if we plug this in either to our original or our new function in vertex form, we can see that that's going to equal 40,000. So this just verifies what we could see graphically. Alright, so now you can see some word problems, how they can use completing the square to help us solve that as well.